we're going to discuss about reconfigurable VLSI architecture. Outline of this presentation: what is the need for reconfigurable computing, type of reconfigurable structure, difference between two main structures, about coarse-grained reconfigurable architecture and their applications. Objective of reconfigurable architecture: reconfiguration. Why we need for reconfiguration? It is change the targeted area and leaving the areas unchanged. So the entire architecture we should not able to modify. Specifically, some portions we can modify and then we get our goal. That is in reconfiguration. Reconfigurable architecture allow hardware structures to implement the functions with any number of inputs bits, that is in bit registers and interconnection resources, shift registers, FIFO and distributed memory resource configurations. Reconfigurable computing combines both the software and hardware in the form of freedom structure. With hardware, program performance, utilities, flexibility and high performance, the computing the fabrics of FPGA like FPGA. Why reconfigurable computing is important? That is, in reconfigurable computing facilitate the faster and more complex computing by using reprogrammable integrated circuits to process the data and solve the problems. And then what are the reconfigurable architectures for general purpose computing? Performance and flexibilities can be obtained from the reconfigurable computing systems such as FPGA and CGRA as an intermediate architecture. Performance in the form of parallelization of architecture and flexibility is in the form of configurability of the architecture. The types of reconfigurable structures: field programmable, very large scale integration, central processing unit, defoxation and DSP are the structures. What is the coarse grained reconfigurable architecture? Mostly CGRAs are hardware accelerators. These accelerators used in multimedia applications with required only an integer operations in most of the cases. We design a CGRA with a multiple floating point unit means it supports the high performance computing. Structure of CGRA. Now why the researchers give the attention to the CGRA means it provides a high performance, high power efficiency and high flexibility. PERAs run in a parallel way such as enables the coarse grained architecture within various application types. The significant advantages of CGRA over FPGAs are the memory configuration time and the reconfiguration times and complexity of the placement and routing is very less. The CPU, memory and reconfigurable ALU array, their interfaces make up the CGRA. Like a morphosis system having an RISC and CPU, main memory, and DMA controllers and reconfigurable core modules. Support for both single instruction and multiple data and loop pipelining. That's why the researchers are give the attention to it. This is a basic block diagram for an CGRA. In that we have a main memory, main processor, buffer, and processing element configuration cache. So CGRA consists of these things: main memory, main processor, and reconfigurable array interfaces. Then RAA reconfigurable array architecture indicates the processing of elements contains in functional units with a multipliers and shift registers, and then PEs are connected with the neighboring units with the top to bottom and left and right. In addition, they have limited interconnections, column wise and row wise. RCM has an PEAs, has an many set of data memory and configuration. These interconnections are reconfigurable because the input multipliers each as PES as an inputs, and each context squared specifies the several inputs for the input multipliers. This one PE structure configuration thing, that is in context register. So context register is nothing but an 32-bit, and that 32-bit we have a 0 to 11 is a constant, and then for ALU operations, mux PE operations, mux A and ALU SFT, and register files write and write exponential, that things are given here, and then ALU and shift registers, and then interconnections are shown here. The bottlenecks in a CGRA, what is the bottlenecks in a CGRA means? So computational capability of an coarse-grained reconfigurable architecture is a main thing is an context memory bandwidth. It's a bottleneck. And then for traditionally two methods are used for the solve. That is one is preloading, data preloading, and then context in the interconnection intermediate time runtime. This method occupies a small amount of on-chip memory, but it leads the time consumption, and the computational time efficiency get reduced. Another one is a multi-context structure. It is a method to load the context in the on-chip memory at the boot phase. Then for predictable context cache, to address the above these issues with the help of buffering the context inside the CGRA. So this is the generic CGRA bottleneck. So context and external memory. So data are input data are loaded in the external memory, and then computation once completed, that will be transferred with the help of data transfer controller to again external memory. If the in that particular case, if we need a intermediate data, that data also stored in external memory, so that we go for and access the intermediate data results means it is access twice the levels compared with an input data access. So that is the main thing to degrade the bandwidth. So data preloading is a most frequently used approach to hide the input data latency and speed up the data transmission process for data bandwidth. Rather than it reducing the amount of input data, the data transferring data and computation process in parallel. Data preloading method cannot work in a efficiently because transmission becomes critical path, means it cannot support a hierarchical data memory. It's a solution for that. In this particular part, high internal bandwidth is provided for the buffers, both reused input data and intermediate data. So HDM resolve these three things. The burden of the external memory from data transfer burden of the data buses are significantly reduced, so it improves the performance. A conclusion of this particular presentation: benefit of CGRA compared to the other reconfigurable techniques. It should be take a very short time to call reconfiguration, and number of control elements in that particular pass small, and designs can be done on high level or world level arithmetic is used. Nowadays it is very wide application in multimedia applications. And as the image enhancements is a very popular one. These are the reference I followed for that presentation. Thank you one and all.